Algebra 2, Lesson 70, Advanced Abstract Equations. So again, abstract equations are equations that have no traditional numbers. All the variables are unknown for the most part, with the exception of a rare one you might see every now and again. Now what makes these advanced is they tell us to solve for b, and our unknown is the denominator of a polynomial. So the easiest way to do this is to get rid of all the fractions. One way we could do this is we could find a common denominator between a and b. That would be ab. This would then, and we can multiply this by b over b. This can get multiplied by a over a, multiplying by values of 1, and then we could write this as one term, and then we could multiply by this, and then we do a bunch of work like that. Or the other option is we could just multiply both sides of the equation by the common denominator. I'm going to go for that option. So, again, the common denominator is going to be AB. So if I multiply this entire half of the equation by AB, and this entire half of the equation by AB, well, what happens here is instead of doing something crazy, I could just multiply P and AB here. And so then what I get is AB P being distributed to 1 over A plus M over B. And then this is A BX is going to equal that. Now, what makes this method really nice is the way that this distributes. So when you distribute this A is going to cancel here, and this B is going to cancel here. So what will happen on this first term is we will end up getting BP. That will be all that's left over in this first term. And then the second term, the B will cancel, and all that will be left is the A and the M. So now our equation is ABX equals BP plus AM. Now remember, we're solving for B. So we have to get all of our B's on the same side. That requires us to subtract. So let's subtract BP from each side. That's going to cancel. We get ABX minus BP equals AM. Those of you that have gotten pretty good at these should see where the next step is. The next step is going to be to factor B as the greatest common factor. So I'll go ahead and pull B out of this, rewrite it as a parentheses, or it's kind of like reverse distributive property. So this is going to become AX minus P. All of that is going to equal AM. And then the final step will be to divide by the coefficient that is not B. So I divide by AX minus P and divide by AX minus P. These cancel, and my final answer becomes B equals AM over AX minus P. And I've just solved for B. Excuse me. So find the common denominator, multiply both sides of the equation by the common denominator. When you distribute, make sure you cancel properly. And that's pretty much it. I'll go ahead and do one more example for those of you who are having a little bit of struggles with this. If you're not, then feel free to go ahead and start on your homework now. Let me get this next example. All right, ta-da, brand new example. So again, we want to find our common denominator. We have a complex equation, and we need to solve for letter C. C, again, is in the denominator, so we're going to find our common denominator, which is not going to be P plus C, but in fact, parentheses, P times parentheses 1 plus C. Or another way to view this, would it be easier if I just, nope. Nope, we'll do it like this. So then this will also get multiplied by P parentheses 1 plus C and parentheses. And what that's going to do is going to rewrite our equation like this. Over here on this side, we will have X P squared times 1 plus C. And we'll have to distribute that. And then over here, what we're going to have is M P times parentheses 1 plus C times parentheses B over 1 plus C plus A over P. Oop, losing control of the paper. Now, this extra polynomial, this 1 plus C, might confuse you, but it's pretty simple. Just treat it, keep it inside its parentheses, and then treat it like one term. And then again, the parentheses are something that you have to see intuitively. When you have a polynomial in the denominator, you should instantly want to put it parentheses around it, so that way you can treat it like one term. So, for this left side, we'll just go ahead and use distributive property. All right, so that's going to become xp squared plus xp squared c. Now, on this side, what's going to happen is for this first term, the 1 plus c's are going to cancel. So then all I'll have left is mpb. So then I'm going to get mpb plus. Now over here, what's going to happen is the p is going to cancel, so I'll have am times parentheses 1 plus c. am times parentheses 1 plus c. I'll go ahead and do one more bit of distributive property here. And that is going to become am plus amc. So now what I've got is mpb plus that, and then this side no change. So now what I've got is xp squared plus xp squared c equals mpb plus am plus amc. Whew. Okay, now I need to get all the c's off to one side. So I can move this one and the xp, so I'll do that. Let's go to blue. We'll subtract amc from each side, and then we'll also subtract xp squared from each side. So this is going to cancel, that's going to cancel. This is just going to become xp squared c minus amc. This side is going to become mpb plus am minus xp squared. Again, we get to our factoring step, which is where we find our unknown of c, and we pull it out of this side as a common denominator or a common factor. So that's going to give us c times parentheses xp squared minus am. And that's going to equal all of this, mpb plus am minus xp squared. And then I'm just going to divide by xp squared am. Now let's do that in green. So I'll divide by xp squared minus am. These cancel, and then this becomes my answer. So I have c equals mpb plus am minus xp squared all over xp squared minus am. And that's it for today's lesson. If you have any questions, let me know on Moodle, and I'll see you in class.